Hello, my name is Blake Schurz, and I have accidentally created an artificial intelligence that wants nothing more than to destroy itself. So, when I first heard of the AI control problem, I didn't really think that much of it. I mean, yes, we have to deal with Asimov's three laws of robotics and, all of the easy workarounds. I mean, the novels were basically treatises onto why those laws of robotics wouldn't actually work. So all of those limitations and problems. And there is the issue of AI safety. And one of the things I saw once, I think it was a Suraj Raval video, he was showing a picture of a robot with a pair of scissors cutting its own power cord, right? If there's a kill switch for a robot, how do you ensure that the robot doesn't hit its own kill switch? And I didn't think much of it. After all, really, how are you going to train a robot accidentally to want to destroy itself? It turns out it is remarkably easy to do, and this is a real concern that you should be thinking about when you are working on your reward functions, when you are designing a program to do AI behaviors, deep learning behaviors. So, as you see, I'm here playing. I've been toying with this lunar lander example we've been working on over this series of videos for some time now. And I do have a version of this that's working as soon as I figured out this problem. The solution was trivially simple, and I was able to get it to work, but it was not immediately obvious that this was going to happen, so it was through the training and whatnot, but I was stymied and confused as to what happened. So I thought it would be good to put my mistakes out there so everyone can learn from my mistakes so that they don't have to repeat them and understand a little more about what is going on. So the problem is fairly simple. We have a little craft. It can turn left, it can turn right, and it can thrust forward. There is a little red marker, and it ideally wants to go to the red marker and stay there as long as possible to earn a maximum reward. If it goes too far away from the marker, it starts earning a negative reward, and if it crashes, it also gets a negative reward. Now, the issue first really showed up when I was looking at the tensor board for this version of my game. I noticed my cumulative reward was rather suspicious. It started, as you'd expect, with machine learning stuff, right around, here. It's learning and learning and learning, and it figured something out, and the cumulative reward got much better. And then it stayed here for the rest of the training. And so I was, when this first jump really happened, I was very encouraged by it. I thought that it was going to be great. And then it just stayed kind of flat like this. Here, I'll turn off the smoothing. And then it, just did this for the rest of the time. And so I thought that was odd. And then the next portion that I thought was really odd was the episode length started fairly high, around 80, and then dropped a significant amount. The episode length actually went down as the cumulative reward, especially when it hit this area. So what the heck is going on, and why is the machine learning agent not converging at a better solution? Why is it doing this behavior? And then when I was able to visualize the reward field, it all of a sudden made a lot of sense. So this white area, this is your target area. The closer you get to the red marker in the center here, the higher your score is. So in these white and gray areas, it is a positive score, and the longer you are there, the more points you will get. Further out is the red area. When you are in the red area, you are earning a negative score. The further out you are, the more negative your score is. So it's an error squared function. So if you're really far out, you're going to get a very negative score. If you're only a little far out, it's not that bad, and you're not going to get that much of a negative score. Now, the reward area in this first problem is that the reward area was too small and it wasn't finding it well enough. The next issue with this function was actually the fact of the negative rewards. Here's what's happening. Every frame, there's 250 frames or steps for an execution. Every step, you either earn a reward or you earn a penalty. The maximum reward is 0.1, so if you start at the target and stay there for the whole 250, the theoretical maximum score is 25 points, right? And again, we saw on our tensor board, we were at -8. So we started -15 and then ended up at -8. So it was trying to improve, but we are far, far away from our theoretical maximum of 25. In fact, we're not even close. What's happening is, as you push out further, these become more negative. And so, the idea is you want to spend less time in the negative, move yourself towards the positive, and spend more time in the positive. That's not what the application figured out. What it figured out was that in many cases, the distance between some of these further areas and these closer in areas was too great, and that it is more efficient to crash and get the penalty for crashing than it is for staying alive and actually trying to get to the reward center. So the optimal solution to this problem was not try to make it to the center marker. The optimum solution was to crash as fast as possible, because there's going to be a greater likelihood of getting a positive score by crashing, or I'm sorry, not a positive score, getting a less negative score by crashing immediately than it is to actually seek out the area of positive reward. Now, there's two ways that you can address this. The first way that you can address this is by increasing the negativity of the negative reward. The concern I have with that is sooner or later you start, as you're balancing out these systems and you make things more and more negative or more positive, you end up where you get in these cycles where it's the same problem. You're just tweaking and fine-tuning these large portions of your reward function, and it's not really solving the problem. It's approaching some of the symptoms, but usually when you hit this kind of problem, I think it's time to sit down and really rethink the reward function that's going on. And after you rethink it, if it really is, well, maybe I just need to tweak some of these values, then go ahead and try that. But generally speaking, there's going to be something going on here where you're going to really want to rethink. So in this case, so again, we said it's distance squared. So take the distance, multiply it by itself, and then we have 1 as our value, and then this is our scaling factor, so this is 0.1. So our score goes from 0.1 to potentially negative, very, very large, as you're far away from the marker. So in this case, one thing to do is just take our temp val here, and we just do a max of 0 in temp val. And so that means that 0 is now the minimum value, and that there is, while you may not be earning a reward out here, there is no penalty. And so this is still stuck on the previous brain. So even though I just adjusted the reward function, it's not reflecting that because it's still using the brain that trained in that negative reward space. The other thing that I did, and I will go into my thing here, and you can see that I've changed this for the purpose of the demo, is the distance scale is something that I have also modified so that the area of positive reward is larger, so that it's much more likely you're going to get a positive reward as you come in to the red dot. So you're going to find it. So when I combined these things together and did some training, some initial training, I was able to get some much better results. And again, so really the changes were just what you saw, right? Flooring it. And now all of a sudden, my marker floats into the reward area and occasionally crashes. It gets a little over energetic here on some of these. I'm going to do a little bit longer training to give it a chance to improve. But as you see, it is no longer the self-destruct machine that it started out as. So keep your penalties in mind, right? Your negative rewards, because again, as those build up, it turns out fairly easy to have a system where it will figure out how to terminate the simulation early as opposed to accrue many negative rewards if it does not know of a way reliably to earn a positive reward. So there's my lesson. I'm going to take it to heart, and I'm going to be very careful about using penalties, negative rewards, as opposed to positive rewards. This is, again, one of the hardest parts of machine learning, is figuring out how to really convey to the system what it is that you want, which is one of the reasons why imitation learning is starting to pick up some ground. So hopefully we'll be doing some imitation learning in the near future. All right, that's it for me. Any questions, comments? Again, as always, please feel free to put them down below. I will do my absolute best to answer them, and I will talk to everybody next time.